Hi, good morning, everybody. We are looking at Chapter 12, Topic 1, the Pythagorean Theorem and special right triangles. So first of all, the Pythagorean Theorem describes the relationship between the sides of a right triangle. The sum of the square of the legs is equal to the square of the hypotenuse. The hypotenuse being the longest side, which is across from the right angle, the 90-degree angle. This can be used to determine side lengths of right triangles. As long as we know at least two of the sides, then we can solve this equation for the last side. So for example, what is the length of the missing leg? So we have leg squared plus leg squared equals the hypotenuse squared. We got a squared plus 64 equals 100 minus 64. A squared is equal to 36, which means square root both sides, a is equal to 6. So the missing side length over here, according to the Pythagorean theorem, is 6. We also want to talk about special right triangles. There's two of them in particular that are relevant here. The first one we want to talk about is the 45, 45, 90. Now, in both of these triangles, all the sides are referenced from the shortest leg. Okay, so in this case, the shortest leg, both the legs are actually the same length. In a 45, 45, 90, both legs are the same length. And the hypotenuse is the leg length multiplied by the square root of 2. So for example, in a special right triangle, we only need to know one side because all the sides are expressed in terms of each other. So as long as we know one side, we can find the rest. So for example, find the missing length of the special right triangle. This is a 45, 45, 90. And our legs are the same length, so x and y are equal to each other. And the hypotenuse, which is 1, is equal to the leg multiplied by the square root of 2. We can solve this for a variable x by dividing by the square root of 2. And we get x is equal to 1 over the square root of 2. Now you can't leave radicals in the denominator, so this is a very simple fix. Multiply both the top and the bottom by the square root of 2. What this does is it squares the square root of 2 on the bottom, which becomes just a regular 2, and then the numerator is now the square root of 2. So this is our missing side length, x. It's also the other side length, y, because in a 45, 45, 90, the side lengths are the same. The leg lengths are the same. We have another example here. So we have, actually I'm going to change these. Well, this one can be B, but I'm calling the hypotenuse C. That's just normal. Okay, so it's a 45, 45, 90. I know that both legs are the same length, so they're both 2 times the square root of 6. And I know that the hypotenuse C is equal to the leg length multiplied by the square root of 2. So we get 2 square root of 12, which is 2 times the square root of 4 times 3, which is 2 times the square root of 3, which is 4 times the square root of 3. So our hypotenuse here is 4 square root of 3 for this example. The other special right triangle we want to look at is a 30, 60, 90. In a 30, 60, 90, the shortest side is across from the smallest angle, the 30-degree angle. The shortest side is across from the 30-degree angle. The longest side, which is the hypotenuse, which is across from the 90-degree angle, is twice the length of the shorter side, of the shortest leg. The hypotenuse is twice the length of the shortest leg. And the other leg is the shortest leg multiplied by the square root of 3, which is the longer leg is across from the bigger angle, so it's across from the 60-degree angle. All right, so these require a little bit more work because we have to set up at least two equations. So first we have to identify the short side. Okay, the short side is right here, y. So everything's going to be expressed as y. First of all, we know that the hypotenuse, which is 1, is twice the short side. So it's 2 times the shortest side, which means that the shortest side is 1/2. Now we also know that the longest leg, which is across from the 60-degree angle, is the short leg multiplied by the square root of 3. So this leg here is the square root of 3 over 2. And now we have all three side lengths for this right triangle. Our next example, find the missing side lengths, simplify all radicals. So first we identify where is the shortest leg. So here's the 30-degree angle. So the shortest leg is y. Now we know that the long leg, which is 4 square root of 6, is equal to the short leg multiplied by the square root of 3. So I can solve this for y by dividing by the square root of 3. So we got 4 square root 6 over square root 3 is equal to y. Now since the square root of 6 is just the square root of 3 times the square root of 2, I can actually cancel the square root of 3's here. So my short leg here is 4 square root 2. 4 times the square root of 2. My hypotenuse is supposed to be 2 times the short leg, so it's going to be 8 times the square root of 2. Just multiply this by 2, and we get our hypotenuse, which is 8 square root of 2. Now I've got all three sides, and that's what I'm trying to find out here. All right, and that is the Pythagorean theorem and special right triangles.